presentation of Lab 5. I am Haryo, and maybe you can introduce yourselves.
I'm Lohausin.
I'm ZHIN.
I'm Lim Hong Yun.
And I'm ZHIN.
Okay, all right. I suppose we'll just jump right to it. For the first task, I'll just load the libraries real quick. Okay, so the libraries are loaded. Right. Okay, so yeah, it's taking. So okay, is it loaded already? Okay. I suppose we can look at the Titanic dataset as well. So maybe I'll explain a bit about the Titanic dataset here. So we essentially get it from this link right here, and we assign it to this variable, right? And since it is in the form of CSV file, we read it in the CSV files. This notation right here is to actually try to simplify the code so it's easier to use. So it's easier to see as well, to read, right? Because readability is important. And so essentially the Titanic dataset has a lot of features, but we only select the survived feature, which will be our Y, embarked, sex, siblings and spouse, the number of siblings and spouses, the number of parents and children, and last but not least, we have the fare. But yeah, the Titanic dataset, it has a lot more features, such as, for example, the passenger class as well. Yeah. And then we turn the embarked and sex features into factors because the embarked and the sex features are categorical, and I think it would be a lot more convenient if we just turn it into a factor variable, right? So yeah, okay, that's done. So let us try to see the object Titanic structure, right? Okay, so this is how it is. So we can see here, the survived is actually in the form of integers, represented as ones or zeros, right? Or whether the person survives or not. So essentially, it's a boolean, right? So embarked and sex as well, represented by factors. It is categorical. Embarked has 3 levels: C, Q, and S, and sex has a female or male. The number of siblings and spouses. This ranges from 0 to like 5. Parents and children as well, like 0 to 5, I think, around there. And the fare as well, so it's numerical, right? So every person is different for the fare. Now we try to check for missing values, right? And I actually included an alternative code to check for missing values, in which this line of code right here tells us like the number of missing values in each feature. But I think it would be a lot more convenient if we use this one line of code, the next one. So this one essentially tells us like everything. So here, as indicated by the output in the console, we have 2 missing values in the embarked feature, right? And 1 missing value in fare. So in fare, since it is numerical, as we can see here, it is actually easier to manage because we can just literally fill the data with mean. And since there are a lot of rows, right, in this data set, and only 3 are missing, so it's not very significant, and therefore we can use these methods to try to replace the missing values, right? And yeah, for fare, we can use the mean, which is right here, the mean function, and we can assign it to whichever is not available, is NA, right, in the Titanic dataset, the fare column, the fare feature. But the embarked feature is actually a factor, right, categorical, so it has 3 categories, and therefore it is not as easy as finding the median or something. Like we have to replace it with mode, right, since it is categorical, and that shall be explained further by my friend Lim.
Okay, I will continue the code. We start from the line 46 first.
Okay, yes.
Let's run the line. Or we have run it. First, we fill the missing value for the fair column using the mean. Then we continue the next code. Alright, in this code in line 49, we actually use the table function and we show the embark attributes, and we can see the value of the embark are actually categorical. The values are C, Q, and S. So because it is the categorical representation of the data, so instead of using mean, we just use mod in order to replace the missing value. So we create a function to calculate the mode. First, we list the distinct and the unique values. Then we count the occurrence of the each of the distinct value. And lastly, we return it the value with the highest occurrence in order to get the mode. Right. So next, we replace the miss value with the using the mod we just created just now to replace the missing value of the embark column. And last, we check again if there is any missing value. And the result says 0 rows. So we have successfully filled up all the missed value. So the next one will be continue by my friends.
Okay, thank you. I will continue the line 71. So first of all, we are going to set a pseudo random number by using the set seed 1, 2, 3. So after that, we are going to split the print test by using the sample split and name it as the sample data. And the condition is split ratio equal to 0.75. So we run the line 74. After that, we are going to create a train data by using the subset function, which the train data and the sample data is equal to true. So we're going to create a train data. And next, we are going to create another test data by using the subset from the Titanic data, which the sample data is equal to false. So after that, we are going to plot the decision tree by using the train data, and rename it at R3 by using the rpart function. And we're going to plot the R3 by using rpart.plot. Okay, we can see here the plot is at the right hand side. So after that, we're going to plot another condition parting plot. First of all, we're going to create the C3 data by using the train data and plot it using the plot function. So the plot tree is can see at the right hand side of the window.
I'm sorry, it's a bit slow because my CPU is yeah.
Okay, so we're going to proceed to the lab 5 task 2. So I will pass to my friend to continue.
Okay, so for that 5 task 2, first we'll clean off everything. And then we'll import the libraries that is needed for this task. So these 4 libraries. And also we'll import the iris dataset. Okay, so next we will try to split the data into training set and also testing set. So we will make use of the create data partition function to split the data. So we will split the iris dataset. 70% of the dataset will be assigned to training set. And as you can see, line 28, we'll assign it to the iris train variable. And after that, we will assign the remaining 30% of it into iris tests. This is for the testing purpose. So 45 of it will be used for testing, and 105 will be used for training out of the total 150.
Oh, sorry. We don't need to show. Okay. Just need to go.
Okay. So next, we will use the train function to train the data set. So we will train iris underscore train, and the method that we will use is recursive partitioning. So we will assign it to the feed dt, and I'll pass on to my friend Juan to explain further on.
Okay. After we train the decision tree, we need to get the description of the decision tree. So we're using the FitDT final model, and we can see the description of the decision tree. After that, we can see the decision rules of it by using the rpart.rules of the data, and we can see the rules for the decision tree. And after that, we can block the decision tree by using the method rpart.block, and we block the decision tree. Yeah, so this is the decision tree. And after that, we need to get the prediction of the data. So we're using the predict function to predict the data, to make the prediction for the data set. So after that, we'll create a confusion matrix of the iris data set using a confusion matrix. So this is it.
Okay. All right. I suppose this is it for our Lab 5 explanation. Thank you for listening, and yeah, we're checking out.